Oceans Overview Notes, gang, by Mahoney and Gebhardt. Make sure you are taking notes on the paper that was provided to you in class. The essential questions you need to be focusing on as you watch the notes and write things down. What is contained in ocean water, and what features make up the ocean floor? So as you're probably aware, ocean water covers much of the Earth. 70% approximately of Earth's surface is covered by oceans. So ocean water contains salts and gases in general. Salinity is a measure of the amount of salts present in a body of water. So the most common salt that you're going to see in ocean water is NaCl. This is sodium chloride. It's just regular table salt, but other salts are also present. Salt ends up in the ocean as water moves all across the land. So different minerals and things, salts are dissolved in fresh water, and eventually they're deposited into the ocean, just as all fresh water leads that direction to the oceans. Density, as we talked about with our properties of water labs and discussions last week, is the measure of the amount of matter packed into a given volume. The higher the water's salt content, the greater its density. So if you look at a couple of beakers that have water in them, if this one has just water, and this one has water plus all of these salt particles that are all packed into the same amount of space, this is going to have a greater density because it has more matter packed into that same amount of space, so its mass is higher and its volume is the same. And that, of course, is density. Salt amounts vary. It's important for you to realize that ocean water is not the same everywhere. It's different. Salinity is lower where ocean water is diluted by fresh water. So if a river is meeting the ocean, then that water is going to have a lower salinity. Very cold areas where ocean water freezes, the salinity is going to be higher because the ice is not going to contain as much salt. Salinity is also higher in areas where it's very warm and the water evaporates quickly. So as the water evaporates, it leaves the salt behind, just like if you have a baseball cap on when in the middle of summer and you get all sweaty and then it dries out and it leaves that white crusty stuff behind. That's the salt that gets left behind when the water from your sweat is evaporating. The ocean's salinity is lower in areas where there's a lot of rainfall also, because all that rain is fresh water. There's no salt in it, and so it brings the salinity down. So this is an actual picture of the Dead Sea, and this gentleman is not sitting on the sand on the bottom. It may look sort of like he is, but he's not. He is floating, and the reason he can float in the Dead Sea is because the salinity is extremely high, which means that the water is very, very, very dense, and therefore, comparatively, he can float higher than he would in regular seawater or ocean water or fresh water particularly. And why do they call it the Dead Sea? It's so salty that there are very, very few organisms that can withstand it and actually live in that water. Therefore, it sort of got the name the Dead Sea. Here you can see also, this looks almost like it's ice, but it's not. That's all salt. As this ocean water splashes up onto what's probably a tree branch or a log or something underneath there, the water evaporates and drips away slowly. As the water drips and evaporates, the salt is left behind, creating these giant crystal structures that you see here. Oxygen and other gases dissolve in the water, just like they do in fresh water. As the water waves are happening, it's coming in contact with the atmosphere above, and oxygen and other gases can dissolve in that water. Same gases as the air. Dissolved gases are essential to ocean life. So, if this poor little fish doesn't get any oxygen from the atmosphere, he's not going to be that happy fish. He's going to be that sad fish. Now, not only does salinity and ocean gases and all of those things vary in oceans, but ocean temperatures vary as well. The surface layer is heated by the sun and wind and makes it the warmest layer. The thermocline is a very important term for you to be sure to remember, is where the temperature drops very quickly as you increase depth. And then deep water is cold all year round, just similar to what we talked about with lakes, that the water at the bottom is going to be much cooler and stay that temperature for much of the year. Alright, so what I have here is a graphic representation of what the ocean temperature layers. Up here at the surface, it's not very deep. Surface temperatures range from 0 to 40 degrees. So you have relatively warm water for most of it, depending on where, of course, you are in the ocean, or where on the planet. In this section, however, as you increase depth, the temperature drops very rapidly. By about 1,000 meters, the temperature in all oceans is 5 degrees C or lower. As you continue down, notice that depth is increasing, but the temperature doesn't change a whole lot. So you can take a look and read some of these things to give you good information. Finally, we're going to talk about features of the ocean floor: continental shelf, the continental slope, the abyssal plain, deep ocean trenches, and mid-ocean ridge. So get ready for the next slide, and I'll show you what those things look like so you know what to look for. So you see this diagram here. We have got the continental shelf is this relatively flat-ish part of the ocean floor that is really the edge of the continent, but it is below the ocean water. The continental slope then starts to drop off, and that's where we have a steeper slope where the water's getting deeper and deeper and deeper. And the abyssal plain is at the very bottom of the ocean. It's at one of the deepest areas, and it's a plain, just like the Great Plains. They are relatively flat. The deep ocean trench is the deepest place on Earth. Deepest places on Earth. In general, that's where you're having convergent boundaries, so you have two tectonic plates, and one of them is diving under the other one. And this is the deepest portion right there. That's a trench. And a mid-ocean ridge is this right here. Hopefully you are familiar with that already from when we talked about plate tectonics. That's where the two plates are moving apart from each other. New magma is coming up from the mantle, and mountains are being formed. So you have a huge mountain range. That is the mid-ocean ridge. If you have questions about this, make sure to see your teacher. Essential questions again. First, what is contained in ocean water? Second, what features make up the ocean floor? If you have any questions, make sure that you write them down on your notes page and come into class ready to ask those questions and get after it in class.